Another question which we are going to explain: coordinates of the stationary point of the curve and determine whether the value of y at each of these points is a maximum or minimum. So for doing that, what we have to do, for stationary point we need to consider dy by dx equals to 0. This is our main uh, theory to do that question. So first let me differentiate dy by dx. If we differentiate here, we got from there 3 to the 6x square minus 6x minus 12. From this expression we got the value dy by dx. That now we are considering 6x square minus 6x minus 12 equals to 0 to get the stationary point. Let us take 6 common, then rest of the part is x square minus x minus 2 equals to 0. So usually you can write that equation x square minus x minus 2 equals to 0. It's easy to middle term break now. X square minus 2x plus x equals to 0. So we can factorize now x minus 2. If we take plus 1 common, x minus 2 equals to 0. So two values of x we are getting from here, x minus 2, another factor is x plus 1 equals to 0, and x we got from there 2, another one minus 1. This is the x value of the stationary point. So now we are going to find out the y value at that particular x value. When x equals to 2, what is our y value? So we can use the calculator to do that. So let me use the calculator. How to do that I'm going to show. In our calculator we need to write the expression. Let you write 2 alpha x. When we are using the alpha button for this two particular value, one is x equals to 2 and another one is x equals to minus 1 to get the value of y, then one time we needed to write the equation in our calculator exactly the way it is written here: 2x cube then minus 3x square 3 alpha, this is the x on the first bracket, it is written here as a pink color x square minus 12x then plus 6. So we already wrote the equation exactly what written as a y. Now we needed to press the button, calculate button, CALC, it is written here, calc. Then the calculator is asking for the value of x here. So our first value of the x is x equals to 2. Let me put it here, 2, then press equals to, and we got from there minus 14. So we can write here for x equals to 2, y value is minus 14. So our coordinate is 2 comma minus 14. This is our one stationary point out of 2. Another stationary point, when x equals to, we got the value minus 1, put here minus 1. Now let me use the calculator again to get the value. So we do not need to write the equation again, just press the here again. Definitely calculate is asking for another value of x, which is minus 1. We are putting the minus 1 equals to, it gives us 13. Okay, the value we got from here 13. So another stationary point which is minus 1 and 13. This stationary point you also can say maximum point or minimum point, or highest point or lowest point. Now our task is to determine whether this value of y, I mean this stationary point, whether it is maximum or minimum. So for to do that we need to differentiate again the expression of dy by dx. This is the dy by dx. Let me differentiate again, which is called the double differentiation, d square y by dx square, which is actually d by dx of our previous expression, that is 6x square minus 6x minus 12. So if we differentiate from there, it gives us 12x minus 6. Now we are going to put the value of x. The first value of x is 2. Let you write here When x equals to 2, then double differentiation d square y by dx square, it gives us 12 into 2 minus 6, which is 18. So 18, that is completely a positive value, positive value. So actually positive value stands for the point is minimum. This is our conclusion. So you can say now 2 comma minus 14, or the value y minus 14 stands for a minimum point. So is a minimum point. You can write here minimum point because we got the value positive. This is the positive value. So next we are going to put the value when x equals to -1, then d square y by dx square equals to 12 into -1 minus 6, which is minus 18. So it's a negative value. Negative value actually stands for the maximum point. So maximum. So now we can conclude here minus 113 is a maximum point. So this is our total working of this expression. Thanks for watching with patience. You are welcome to see my next tutorial.